Greetings, Michael Wickerson here, trying to get my head in the picture. End of 2022 and end of really needing to do all the nuts and bolts of coding. As long as you know enough about it to fix things up, it's a very nice tool for Grasshopper. There's a plugin called Script Parasite, which can be loaded from Package Manager right into your Math tab, and you'll have a script parasite, and so long as you take the script you're writing. So what's nice about this is even though I've done things with it after, literally all I've done is taken the curves and merged them just to build a pipe surface. So I could have scripted pipe in here from all the curves, but I thought it would be nice to show you that starting with a script and writing it in parallel, and then I made it parametric just over here by some number sliders, and I used my famous sine oscillation, and I put on my preferred gene pool. If you're interested in this, you can always take a look at my GitHub files. I'm going to be putting these on through Patreon. But the main thing is this node mimics what goes over to Visual Studio Code, and with that, if you have Github-copilot on your extension, you can just start telling it what to do, and the outputs are just progressive outputs as I build this. So the simple thing to start with, if I take a look over here, if you take a look at what's being output here as a line and some points, curves between those points, just single line curves. I thought it would be interesting to treat them all separate, but basically just probably a more cumbersome script than you need to write to get this to output. But with Github-copilot, you basically, let me jump on Github-copilot. Oh, I just made that too long. Let me just stretch that one over. You can see that I just go in, everything loads directly. I've got a nice little package here that will actually send it to a file. Right here, user objects, and I wrote an additional script courtesy of Parametric Camp that will actually allow me to, where did I put this? Yeah, right here. It basically just is a little C script that's shared on Parametric Camp, and a little bit of script in there will actually output this every time that I save this file, or anytime I do anything to it, it will save automatically to my folder development on my desktop. So if I even start to change these letters, every time I change a letter, it's like it uploads. So you have to make sure that you turn that to false before doing it. So just play around a little bit with Script Parasite, but the main point is to bring your stuff into Visual Studio Code. And in doing so, then with the power of Github-copilot, you can just start saying what you want to do. Create a pentagon centered around the origin with radius 1, and the script comes up automatically. As soon as I have that pentagon, and I don't need to have it in oscillation, but I think it just makes for a more interesting looking script, create a polygon, which basically does that from those points. Creates a polyline. And that normally would look like a pentagon because there's 5 points. And they were positioned in a way that I thought, well, let's bring them in as inputs, because there's no fun with the C node if you can't do anything to it. If you can't change the scripts, and it's just hard-coded in, what's the fun of that? So it's better to make your C# scripts parametric. And I'm going to pair these script parasites scripts 002 with create polygon 002. So really, I'll just have one node for each one of these files. You can take a look at it. You can take a look at the script in it. And if you have Github-copilot, just write your own scripts. It's really eliminating the need to get into all the details and debugging all this, because so many script has been written. As long as you have some knowledge of script, you can follow along what's happening. The lists are being made. And I said find the midpoints of the polyline segment. So I'm thinking and doing what I normally do in Grasshopper with wires and nodes and moving them around, making these spaghetti shapes, and then just having fun with it, which is kind of evident with my oscillation tool, because I haven't scripted my oscillation tool. I probably should, and then just have that in one node. But I like to keep things parametric and playful, so I can get in here and I can play with these different values to really adjust what's happening. And since it's a gene pool tool, I can just blast it into another shape and get another dance. So I just think of it as a little, linear, whatever, point-driven dance, ballet. And I'll probably call it that. For inspiration, I just look at whatever, any files, basic Rhino files, taking a look at PJ Chen's jewelry files to get inspired. This was actually made by just the idea of coming up with a pentagon to start and deciding what to do with it. Then I typed in find the center of the points, generates that. Anytime I update this or hit save, it'll run the script again, and there it is. It starts again. So whatever's updated here will run it over in C, which is amazing. Find the center of the points. Then I want to move. What happened there? No, that's fine. Just want to move the points. Probably should just format this again. Find the center of the points. Move the midpoints halfway to the centroid, which is what I did to kind of scale down. Move the midpoints up by 1, so I could make that parametric as well. I could change that 1 value there. Instead of moving it by that vector, I could apply a vector that would change that and put it through oscillation. So break down what you know in its most base components, thinking of points, and then moving that into line work. Create a list of lines that connect the midpoints to the original points. It's not that big complex geometry. I just like my oscillation tool to appreciate it in many different ways, and I like that this little script generated an output all stages of my process, lines 0 through 4, well, 1, 2, 3, 4, 5, the lines coming up to the midpoints. And then all the data before, with GitHub-copilot, it basically guesses at what you want. So if I went back here, if I just comment this out, the best thing about GitHub-copilot is you really don't have to think too hard. Just give it a second, maybe prime it. I always call that kind of priming it. And it should, I don't know why it's not. There it is. Lines is finishing for me. So once it guesses at what you're doing, you're pretty much set. So I'm just going to bring that back. I'm going to uncomment that so E works. Save it again, and of course it'll kickstart my script again. And you've got a wonderful geometry you've made, a simple tutorial using Visual Studio Code with GitHub-copilot, using a grasshopper, basically just using C scripts all the way down. This is a nice little, basically what's in here is exactly what gets updated. I don't have to debug in here, because I can debug over in Visual Studio thanks to Parametric Camp. So I think I'm really on to something. Anything I was conceiving to maybe do in Grasshopper, I can literally text to script, do it in one node. So there's no need to write long, wiry scripts unless you enjoy doing that, which I kind of like, being playful and getting into it. I don't have to pack it all into the node. Once the node gets a little too many lines of script, it probably will have too many inputs to play with, so at that point you'll probably want to break it into different things. The problem is you have to have a new Visual Studio script for every one of these paired with an enable, and that gets a little funky. So you've got to try and pack down as much as you can into a node and see what happens. But I call this just the ballet, and I think it's a nice ballet simulation using script, C script Parasite, GitHub-copilot, Visual Studio Code, getting the math in there just by asking for it, and keeping the geometries pretty basically simple enough to enjoy. And I thought I'll go back into my series I did in Grasshopper 2 dealing with Euclid's elements, because this is going to be a wonderful way to script and logically prove and make animations for Euclid's elements. I don't work for anybody on this stuff. I do it because I enjoy it. I think I keep finding these little nuggets of play, and I hope people enjoy it. I will share these scripts on the new direction I'm going with Patreon, just because there's a lot tucked in here. It's probably easiest just to get a hold of the script and have a peek at it. You'll have to learn the basics of getting up some of these nodes running, but it's not too hard. And if you have questions, you can always reach out to me. Stop streaming and stop recording.